Centrifugal pump tutorial number 8. A centrifugal water pump rotates at 800 rpm. B1 equal 50 millimeters, B2 equal 25 millimeters, R1 equal 40 millimeters, R2 equal 125 millimeters, beta 1 is 45 degree, and beta 2 is 30 degree. Assuming no angular momentum at fluid at the blade entrance, determine the ideal flow rate, pressure head rise across the impeller, the theoretical torque, and the power requirement. First, what you need to do is you need to draw the velocity triangle. This is the velocity triangle, and we have 30 degree here and we have 45 degree here. There are no whirl 1 at the inlet, so the triangle will become like this. To calculate the velocity u1, we could use this equation, and we could calculate it is around 3.35 meter per second. Then, by using the trigonometry idea here, we could calculate the velocity Vf1 is equal to 3.35 meter per second. And finally, we could calculate the flow rate by using the idea of Vf1 times pi d1b1, and it is equal to 0.0421 meter cube per second. Next, we need to calculate pressure head rise across the impeller. So it is mean that we have blade here, and we need to calculate what is the pressure head difference from here to here. But the idea of pressure head rise is equal to Euler head. So in this question, actually we need to determine what is the value of Euler head. So we write down the equation of Euler head, and because there is no whirl1 at inlet here, so the equation for Euler head can be simplified like this. To calculate this one, we need to calculate the value of u2 and whirl2. We could calculate u2 by using this equation, and it is equal to 10.47 meter per second. And then we could calculate the Vf2. It is equal to 2.14 meter per second. Then we could calculate whirl2, and it is equal to 6.76 meter per second. Then we substitute all the values into this equation. We could calculate that Euler head is equal to 7.21 meters. Then we could calculate the theoretical torque by using this equation. We already discussed about this equation in notes. Please check my previous lesson. We know that whirl1 is equal to 0, so we could simplify this equation. Then we substitute with the value of whirl2 and R2 here. We could get torque is equal to 35.6 Newton meters. Finally, we need to calculate the power requirement. Power can be calculated by multiply torque and omega. And omega can be calculated by using this equation, U over R. So in this situation, I would like to use U2 over R2. We substitute all the values, and we could calculate omega is equal to 83.76 radian per second. We substitute the value of radian here, the substitute of value of omega and value of torque that we calculated previously. We could get the power requirement for this pump is equal to 2982 watt.